In this video, I'm going to show you how I created a Google Scholar scraping automation in make.com, how we're going to get citations and how we're going to get the actual complete research paper. Then we're going to summarize the data to extract key points from these. And then we're going to use this data, or you can use this data, to create complete articles based on research data with correct citations in them. My name is Hans Theisen. I am a automation and product developer. I own Scale by Tech, and we help SEO agencies and website owners implement content scaling automations. So without further ado, let's get into the video. Let's get into building. I've done this in a bit of a different format. So instead of me adding all the notes and building them in real time, I'm gonna assemble the script here with pre-built notes and then show you what's inside in order to speed this up a bit. So this ain't gonna be a 2-hour long video, because it's boring and I would like to speed this process up for you. First of all, we're going to start in make.com. I'm using BoostSpace integrator, same platform, with a webhook. So I'm going to create a custom webhook, and then I use AiTable for my interface. You can use Airtable as well, it doesn't matter. I'm going to hook this up with an automation that when I trigger something, it will send the request to the webhook. And in my articles, this is when I click on Get SEO. This is my trigger for scraping data. And we're going to do the testing on line main mushroom benefits and Reshi mushroom benefits. So whenever I do this and click 01 Get SEO, we're going to trigger the script and we're going to get the record ID here. I then have a variable node. I'm not going to show you this one up here because that has all my API keys in it. Anyways, we have AiTable API key, we have article datasheet ID, and this site datasheet ID, keys, and summary. This is just so I can pull the article. For example, I will then be able to pull the record here because I'm gonna link to this specific datasheet ID. Instead of hard coding it, I have it as a variable pulled out so I can easily exchange to a different template or installation. And the same goes for site and database keys. They have a lot of different information here. Anyways, the first thing that we're going to do is we're going to get the article record ID here. The API call looks like this. So we're going to get the record ID from the datasheet ID up here. We have an API key and that's it. Then we're going to update that specific record. And that is because I'm going to change the state to in progress and then update when it was in progress, which means that the state here will change to in progress. And last update, it will change here so we can see that something is actually happening and when it started to happen. Then I'm going to get the site, the linked site over here. So this one here is going to pull from this data sheet up here to get information from this. And then I'm going to get some more keys from the data sheet keys one. I'm specifically going to get my DataForSEO hash key from this one. Awesome. Now we're going to add a search intent node. This is a ChatGPT node. What we're going to do in this specific node is we're going to take the main keyword. We're going to ask ChatGPT to create a search intent and content expectations summary of when a person searches on Google for this one, line main mushroom benefit. What is the actual search intent they are after? And the prompt looks like this. You're an SEO expert helping to determine search intent and content information expectations for keywords. Give a detailed description of the search intent and content expectations for the following keyword. And then I'm going to add the keyword here. Do not use more than 100 words to describe this. Format the output like this. Search intent equals to content expectations equals to. The reason why we're doing this is so we have a very concise answer to or information about what should this article be about, like how should it be structured, what are we trying to do. We're going to try to solve or give the person searching for line main mushroom benefits, we have to fulfill their search intent as fast as possible. So this is why we're going to start with a search intent, so we got that clarified, like really solidified. What are we trying to achieve here? Then we're going to add a repeater, but this is actually a if statement. we can turn a repeater into an if statement. And this is something, if you worked with make a lot, there's no if statements in here, but you can use a repeater and then use an if statement in here to turn a repeater into an if statement. So you run an if inline with the script. That's a bit technical, but it's very, very handy when you know how to use it. We're gonna look for this specific field here. So we're gonna look for this field. If this is checked, then that's a Boolean function, which means that it goes to 1. So if that field equals 1, then we're gonna add or set the repeater. Whoops, sorry. So I can do this as well. So if this is 1, we set the repeat to 1, which means that it will repeat 1 time. If this is not checked, the repeater will be set to 0 and it will not run. So this is actually just an if statement. Pretty handy. Awesome. Now we're gonna do 2 variables here, 2 set variables. And this is because we're gonna fill these 2 fields over here. So let's go here. Let's see, we have here Scholar Citations and Scholar Scrape. These 2 fields, we're gonna compile the data from multiple research papers, which means that we're gonna iterate over multiple links and PDFs and so forth. So we're gonna have to have a internal make variable where we're gonna compile or add on data with each iteration. So the first thing we're gonna do is we're gonna set these 2 variables. So Scholar Scrape and Scholar Citations. Great. Let me just move this over here. Got it. Then we are gonna do no, that's actually just to show you that you could do. I'm using DataForSEO for all my scrape. And when you scrape Google Scholar, let me just add on these 2 here as well. So we're gonna do a search on Google Scholar. Let me just go here. Go to Google Scholar. Then I'm gonna take my main keyword. I'm gonna paste that in. And here we got all these research papers in PDF and HTML and so forth. We're gonna do this search, which means Google scholar.google.com / and so forth. And then we are gonna add the main, let me just go here, the main keyword, and we're gonna convert this into an encoded URL and search for that. This is DataForSEO API. You could do this here. Let me just copy and paste this up. Okay. With a simple HTML request. So let me just go here and then paste this in here like so. Then run this module only. We're gonna look at the data and then you're gonna get the HTML. The thing is here that this request will always come from the same server, or more or less the same server. You probably would run into IP blocking. Google Scholar, Google in general, is not super fond of bots crawling around in the same website all the time. So if it gets a lot of requests from the same IP, it's gonna not behave very well. So this might work to get your HTML out here, but I always use DataForSEO for this type of work because it is more robust and we have IP rotation and we can render the page with Java and so forth. So we can emulate actual human search, which is why I have the DataForSEO on page instant here. This is just an API key. Then we're gonna do the same here. So the same URL, but we're gonna enable JavaScript. Yeah, it's gonna pull JavaScript from it. Actually, that is false. Anyways, we have some other nodes further down where this is enabled. Then we're gonna have to add this one, store raw HTML to true, because then we're gonna extract the raw HTML. I know that this one does it in one go, but you will run into IP blocking if you start to run a lot of requests with just simple HTML like get here. So this is just, these two work in tandem. Like we do this first to actually render the page, and then we're gonna call it to in the next one to get the HTML out of it. And that is this one, this API on page raw HTML post. Need to set your API key, content type, application JSON, body type raw, content type, application. You can also use DataForSEO's actual nodes here. I'm gonna show that in a moment. Same request here, and then we have to add an ID. You just go to DataForSEO's documentation to see how that is structured. But this is Google Scholar queue here, and then we get the ID to actually pull the HTML. That is for searches 1 to 10, and then I would actually like to have 20. So 20, a list of 20 that we can pick from. So what I'm gonna do, I'm gonna run it one more time. Then I'm gonna add start equal to 10 and then I'm gonna add the question here, or the search phrase. You can see this if you go to Google Scholar and click next, you will see that your URL just changes to add this start equals 10, which is the next page. And then the exact same keyword phrase. So in code URL is gonna change a simple string into a URL search. And that is exactly what Google is doing as well. We can actually remove this here. We can remove this here. Just search like this, Google Scholar, question, and then line main mushroom benefits. Enter. That's going to do the search. Awesome. And then we're going to get the raw HTML. Coolio's next one is we're going to use an AI node to actually extract which articles we should be looking at. Whoops, there we go. And this is where the search intent and content expectations comes in handy, because we can now feed it the actual search intent and content expectations together with all the HTML data, and then ask it to extract the information that we need. So we're going to structure it. First of all, we're going to give it a system command. Your task is to select 3 PDF or HTML. The reason why I'm writing this as in brackets is because in the raw HTML, the PDF and HTML links are kind of marked with this in front of them. So by showing it these two, it will know that these are specific URLs that we are after. From the supplied raw HTML, you always output in the format, always output in the following JSON format. Then I'm going to give it an example of the output. So we're going to have a source and a URL. So the source is if it's PDF or HTML, and then the URL is just the URL. Rule, you only select PDFs with -DOY-PDF in the URL, or is a nih.gov URL. The reason for this is that Google Scholar or research papers in general are super hard to scrape. And we can replace the PDF here to full, and then we're going to get an HTML. I'm going to show that later. Or all these nih.gov links, which are PDFs, we can take them directly. So I had to add some rules here for PDFs that we can only select these type of PDFs in order to scrape them. All other sites for PDFs won't allow you to scrape the actual PDF. They're kind of hard on you. Based on the below, so we're going to add a user message here. Based on the below HTML, select 3 URLs. The search term is, and then we're going to add the main keyword. The selected URL must help fulfill the search intent. And then I have a line here because we had, if you remember, in the search intent and content expectations AI, we had search intent equal, and then I'm going to write a search intent, and then it's going to write a content expectations on the new line. So I'm going to do a split on the result here for every new line, and then I'm going to take the first one in the array, meaning I'm only going to get the search intent. So the selected URLs must help fulfill the search intent, and then I'm going to give it the search intent. So it actually knows which type of research papers that it should be looking for to fulfill the search intent. This is like very important because you can find a lot of non-usable information for lion mane mushroom benefits, even though you're searching for this, you might get something completely different from, like, for lion mane mushroom growth something. They might have researched how to best grow lion mane mushrooms, so the benefits of planting them in tree bark, whatever. That is not relevant to this search intent, like of the benefits of the mushroom. But we might get it here, and if the AI doesn't know like how it's gonna rate all these links here, it might select something deeply irrelevant to our search phrase. So this is why it's important to have clarified or solidified the search intent prior to doing any AI selection. Awesome. Then we're gonna say always output in JSON, output format, example, and then I'm just gonna give it an example of how that might look. Then we're gonna add the raw HTML. The first line is from the first HTML node, and then from the second one, Coolios. This is gonna output in a JSON format. And stop lagging. Even though like sometimes it's gonna add this JSON wrapper to the output. So I'm gonna have to replace that. So I'm gonna use 2 replace functions on the result. Sometimes it does this, sometimes it doesn't. I always have this when I ask a node here or an AI to output in JSON. I always tell it to replace and then add this here to empty string, and then replace, this is the end of the JSON wrapper, to empty string. So this is a parse JSON node. It's gonna parse the output from the AI node. And then some of you probably know that you can actually have the AI output directly into JSON, and you can also have it parse the JSON to an object. The problem here is that we're gonna output an array. So we have multiple JSON objects. And if you ask the AI to here text respond or respond format, if you set this to JSON object, you're only gonna get one object from this. It cannot output an array, and we are specifically looking for an array. So you cannot do this in this instance. You have to just output it as text and then parse it here to an actual JSON array. Coolios. Then, we're gonna add a counter. Since we're not having, this will output the array, so 3 links to PDFs or HTMLs. Since this is not an iterator, but it will iterate over the outputs, we're gonna have to add a counter here, so we can count for each iteration. So first citation 1, citation 2, and citation 3, or article 1, 2, and 3. So we have them indexed. If this, like, you could add an aggregator, like put this parse JSON into an aggregator, then add an iterator, then have a built-in counter on the iterator. But that would be one additional node. So this is actually more, maybe it's not more, I don't know. I just did it this way. Awesome. Now we're gonna get into the actual building block of how we're gonna construct the information, because this is gonna output, let me just see here. This JSON here is gonna output 3 articles or 3 links. And then we're gonna scrape each of those links for all the data and summarize it. It's gonna run through these 2 nodes here. So we're gonna get a variable here, and we're gonna get Scholar Scrape. If you remember prior in the script, we set these 2 links here. So we're gonna get the Scholar Scrape here, and we're gonna get the citation here, because later in the scripts we're gonna set these variables. So we have to do a get first and then a set function in order to build the variable. You can see how this works when we add more to this. Then we're gonna do a split function or a router function. First route is that if the source, if you remember, we asked the AI to output in JSON format, and it's gonna output in source and URL. So if the source is equal to PDF, remember here, we have source and we have URL as 2 parameters. So if the source is equal to PDF, we're gonna go that route. if the source is equal to HTML, we're gonna go this way. Cool. Let's run this function once and see what it's gonna do. One sec. So I just set it to run once here, going to article, and then get SEO. This will trigger here, go through all the steps, get article, update it, get the site, create the search intent. You can see here, search intent, content expectations, get all the raw HTML. Let's see if we got a 200 status. That worked. And then we're gonna go scholar selection and get citations. Great. We can then see here that we get 3 bundles out. Source PDF, PDF, and PDF. Apparently all PDFs. So they would all go that way here to the PDF section here. We're gonna add this, delete this module, because there are 2 different methods. One is where we get this DOI function here. So if the URL contains this specific string here, DOI-PDF, then we're gonna run this way. If the URL ends with .pdf, then we know it's a direct link to a PDF. That is 2 different options here. So we're gonna add this one over here. And this is, we're gonna parse this content live, get the, that's just the API key here. Now we have to set the JavaScript to true, and we have browser preset here and so forth. Let me just take the URL. First thing we're gonna do is we're gonna take this URL where we included, we have this DOI/PDF. If you replace the PDF with full, that took a bit time to actually figure out. Let me just see if I can find one. No. Maybe this one. Nope. Let me go to number 2. DOI. Nope. Seems like all these are just full. One second. Okay, here we got one. So this specific URL here, we actually can't scrape this as a PDF because this is an embedded iframe. This is an HTML website with an embedded iframe which pulls a PDF from somewhere. We can't pull this PDF, but I found out if you take the PDF up here in the URL and replace it with full, you're gonna get the HTML version of this site. The thing is that in Google Scholar, it will link to the PDF and not the HTML version. So we have to do this workaround where we treat it as a PDF and then we replace the PDF to full in order to get the HTML version. Now we have the HTML version of the whole research paper here. We can then scrape that. So this is what the URL function here does, where we're gonna replace PDF to full, and we have to enable JavaScript, we have to enable browser preset to desktop, enable browser rendering, and this is a switch pool for the IP, so it will switch or rotate IPs, because these sites here really don't want you to use bots to scrape this data here. Like, they don't like that. So if you request this site 3 times from something just as a get HTML, you're gonna get blocked. I don't think you can even get this site from a simple get HTML. It will just block you right away. Like, you have to add this here in order to pass their bot filters, which is why I use DataForSEO. I'm just gonna use that as standard because I don't want the hassle of trying to get it to work. Once we run that is an HTML, we then have to extract all the data. And you get the data back from DataForSEO in a structured way. So you get it back in main content and secondary content and H titles and so forth. So we have to do some iteration and aggregation on the data to extract the correct data. But it's very nicely formatted once we do it in this way. So what we're gonna do is we're gonna take data, results, items, and page content secondary topic, like that specific array. We're gonna go down and find that array called page content secondary topic. We're going to iterate over that. We're then going to aggregate that into a string, meaning just text. We're going to add that as an H, and then the level here is like the H title. So if the level is 1, that's the H1. If the level is 3, that's an H3. Then we're going to add a dash and add the title. So H2 dash the title. Then we're going to switch to a new line, and then we're going to do let's go into this, do a map function, and take all the secondary content, which has the key text. We're going to map that into the map function pulls it into a simple array, meaning that we strip everything else away from that array and only have this content here as a simple array. We're then going to join that array by a new line plus a new line. So two new lines. We're going to separate each of these secondary content sections with 2 new lines. And then at the end, we're going to add a new line, and then the next one will be added here. Yeah, this takes a long time to figure out how to do that. So this will just output a long string of all the secondary topics. Next part is that we're going to add this one here. Same exact function, except that we're going to do this on the main topic instead of the secondary topic. That the main topic versus the secondary topic depends on how the article is structured. Sometimes all the text is in the main topic, sometimes all the text is in the secondary topic, and sometimes it is split. But you actually don't know because different sites organize what is main topic and secondary topic in the raw HTML or the site structure differently. So you'll never know whenever you need to use secondary topic or main topic. That depends on the site. Coolios, we now actually got all the information extracted from this PDF, which we then turned into an HTML site, scraped that, and then we're going to add a not blank, because if we get blocked, it still happens that we get blocked sometimes, that this has to be not blank. So we're going to take the text here, so we can actually do both of these, should be like this actually, that if both of these are blank, that means that they do not exist, and then we're not going to pass the filter. But if we actually extract data from these two or one of them, we have data. Awesome. We can then continue to summarize the actual article. And I'm going to set my connection here. So once we got all the data extracted, we can then feed all that data into a summarizing AI. Because just like taking 3 Scholar articles in full length and passing that on to a article writer, that's too much information. We need to summarize and condense and extract the important information. So this one is just we don't have a system prompt here. We're just going to do a user prompt. Please extract all statistics and valuable conclusions for this research paper. Output them in a structured way. Start with an APA citation for the research paper, then add conclusion and statistics. And this is actually also formatted in a JSON style. So output must be JSON formatted. You can pause this video to look at the prompts in specific if you want that. So we only include 2 objects, APA citation and conclusion statistics. Combine all conclusions and statistics in the conclusion statistics. It's important that connected statistics and statistics explanations are enumerated with the same number, so it is evident what statistics and statistics explanations belong together. When you've played around with like how to summarize this makes more sense. But in general, we want to extract statistics in its own line, so we have a condensed or concise line that we can use in the article. And then we have an explanation to why we actually want to add that line in. So 25% of all people have gotten COVID. Okay, that's a statistic, but why is that something that we should care about? So the explanation for the statistic. We're going to add those in 2 different lines. So when we feed this information into an article writer, the article writer will have an easier time to extract and inject the correct statistics in the right manner. So always use Markdown format for the URL in the APA citation with anchor text being the URL. Awesome. Then we have an output example here of JSON. And here we actually don't want an array. We only want like a JSON object. So here it is okay to set the response format to JSON object because this is not an array. Awesome. Let's see here. We got this. Omit, don't include unavailable APA citation information. It just means that we are not going to include, for example, if the year is missing. So if 2009 is not included with the information that we get, we're simply going to omit and not include the year. Otherwise, it might try to fill in something that is not correct. If some information here is missing, like pages or, I don't know, the first or last name, it's going to omit the information. So we're going to get a citation that is as correct as we can create it based on the information we have from the scrape. That's all it's going to say here. Never add redundant conclusions or statistics. This is just like, we don't need 3 versions of the 25%, saying like 25%, 75% didn't get it, or 25% got it. Same information, so we don't want to add redundant conclusions or statistics. Then we add all the information for the research paper. We have the URL, we have the H title here, and then we're going to add the actual research paper title, which is this one, page content, secondary topic, main title. So if we extract that specific variable here, we're going to get the main title. And the item here is that it is an H1 title here. Oh, it's actually, no, sorry, it's all this here. So we're going to go data, results, items, all the way down. That's the main title, sorry. And then we will add the main content and secondary content, like these 2 text aggregators down here. And lastly, we will select the response format to JSON object because that will force it to output in a JSON object. We can do this because we're not looking for an array. Coolios. Then we are gonna set, now these variables come into play again. Remember that we get a variable here. This is just gonna be blank because we don't set any information in that run here. Now if on the first one we route all the way up here, we extract the information, we summarize it, then we set the Scholar Scrape variable with, first we're going to add the variable. So this is why we have this get function down here. So this is the get function, 23, and it ends with a new line. So it breaks that down as a new line. So if there was something posted to the Scholar Scrape or set in the Scholar Scrape get or variable, it will add that in front of the second statistic here, or citation. Then we're going to do citation number in brackets and then the I. That's the counter here. Then we're going to set the URL, which is just the URL that we get from the JSON here. And then we're going to add conclusion and statistics. And that is the result from this AI. And as you remember, we outputted it as a JSON object. So this is going to be a specific object output, which is why we can like take the result and then conclusion statistics. Then we're going to add 2 new lines. Then in the citation, again, we add prior citations that have been saved to this variable. Then we're going to add the next citation with an I for this is citation 2 or 3, dash, and then the result, APA citation, new line, and that is the APA citation from the AI. Cool. Like that was that run up here. We're then gonna look at the next one because that was if the URL was actually an HTML. The PDF here, we converted that to an, so I'm gonna delete that. If it is an actual PDF, we need to use Cloud Convert. Then we just feed it the URL, import a file from URL. I want to set the specific input, that is PDF. The output is set to txt, and I just set the name to scholar.txt. I have this one ignore. So if this fails, I'm just gonna explain, if an HTML node fails, it will not really fail, it will just give you a status code 400 and then the script will continue. But if this one fails, you'll get an error. And I'm just going to ignore that error because an error might happen here, but the two others might run correctly. So I'm not going to sweat it if this one fails, just going to continue. We're then going to use compose a string because we get the data back. I actually set here this one here, export option, download a file, yes, which means that we extract all the text from the PDF and then we download the data. Awesome. This downloaded data is in data format. It's not a string, which means that we can use this command toString and then convert the data into text. And we now have the text from the PDF. That is like this here is the same as this up here. So we now have all the text, which is the same as these two up here. That means that we can add the summarize Scholar here. And then again, we're going to do this if blank, don't continue. These two are the same. So exactly the same. And then we will add Scholar scrape and set variable for citations. Same as these one up here, just a different route. We're almost done now because this is more or less the last function. I'm going to delete that module. And if you look closely, this is the same up here. So we see that this is a PDF, but we need to replace that in the URL. So this PDF to full in order to convert it to an HTML. And then we run this function up here where we're actually scraping the HTML. The same is done down here, but this is just raw HTML to start with. So this is just like, this is HTML, the source is HTML. Awesome. Just run this parsing live on the URL, JavaScript true, and then we're going to do the same, secondary topic, main topic, then this is the same here, summarize, Scholar scrape, and citation. And this is the text aggregator to close off this one here. So this acts as an iterator, and I want to close off the scrape from here. So let's see, parse, that is correct. There we go. And this is for you technical guys, when you start to use routers, always add the closing parameter on the last router leg. So let me see if I can set this. Can I do that? No. If you had the numbers like, oh, there we go. First, second, and this is first, second. When you close off a route, always close it off with an aggregator on the last leg. Like this will just save you a ton of hassle when you do that. There's a good reason for it, but I'm not going to go into that explanation here. So now we're going to use this bundle here. We have 3 bundles. We run 1, 2, and 3, depending on which links we get. We get this variable here so we can compile or aggregate the data when we set the variables up here. When we're finished with running all this, we will get the final scrape information and the final citation information, because we don't know if we set a get variable here that this will actually be the correct one. Like we have to do it in this way here. Then once these two are set, I am gonna do a transform to JSON. That's because I'm using an HTML node for uploading. So if you add a direct AiTable node, you won't need these two here. But I'm going to use an HTML API call, so I need to convert all string into JSON. This is just converting, transforming this text information into a JSON object. And this is where I use the HTML node. You could use an AirTable node or an AiTable specific node. Then instead of having like JSON here, you would just put that text into the specific field. So Scholar citation is that one. Scholar scrape is this one. Correlates to these two fields up here. And then, yeah, that was standard API call. So we're going to update the record, put the information back into AiTable. And then I'm going to close off my if statement. So we can now see that Scholar close, we go all the way back to the if statement. So again, if my if statement is 0, it will just skip this entire section here. I'll just not run that. The reason why we have that in there, like it's not gonna run this, is because this is only part one, or one part of my get SEO script. Just for information, this is the rest of the script where we scrape other information. But anyways, like this should be done and built now. So let's save this, ignore, and then account open. That's because we need to set these accounts here. Let's run this. We can go here while this is loading and just click get SEO. Is this done loading? Okay. And then I'm gonna set this one as well. And then we should be able to run this script and extract all the juicy information. And I can tell you that getting actual data from research papers, like scraping the real research papers, are really, really hard to do. Run once, use existing data. Then we're gonna go through, search intent. Let's see here. They are likely interested in understanding the health advantages of consuming lion mane mushrooms, possibly for decision making regarding dietary inclusion or supplementation. That's a pretty good search intent. The content should provide specific, scientifically backed health benefits such as cognitive function improvement, neuroprotection, digestive health. Like, it's pretty spot on, like what the search intent is and what content we are expecting to find if someone would be clicking into like a first or second ranked Google page. We can see that we have 3. The first one went up here, which was, we can actually get that now. So we can see that the first one here, that is a PDF, but we had to replace the PDF with full. The second, maybe, actually we got a PDF from that. And the second one didn't go anywhere. Let me just see the second one, or the third one. That was a PDF as well. But why didn't it go here? That was probably the third one. That's because this one, it didn't run the second. So we got number 1 and number 3. But it categorized this one as a PDF, but it's not ending in PDF, and it's not, and doesn't have, like, includes this one here. So it skipped number 2, so we got number 1 and number 3 as citations. So let's go over to article. Maybe we didn't. Why didn't we? Let's see here. Update Scholar Scrape. Yep. Citations. Yep. You can see here in citations that we got citation 1 and we got citation 3. And we skipped number 2 because it didn't fit our criteria. And I just had to update my variables because I was linking to a different data sheet and not the one we were looking at. Anyways, I just ran it again. Now we actually got 3 correct runs here. So we can see in the citations that we have citation 1, citation 2, and citation 3. And we updated the record here. So if we go back to articles, we get scholar citations here, which you can see we get all the information. So we have, all the citation information here. And then we have all the information about like the conclusions and statistics. So we have one conclusion here. Let me just scroll up. Conclusion, daily oral administration, yada, yada, yada. Conclusion here, conclusion here, conclusion here. Then we have a statistic. So you can see here, statistic 5 and 5. So we have statistic recovery of toe spreading reflection, and the statistic explanation indicates earlier nerve regeneration and yada, yada, yada. So we get the statistic and then we get the statistic explanation. For the citation number 2, we then have URL, conclusion, and then we have statistics. So we can see here, statistic, 76% and 81% radical scavenging. It probably makes sense once you read the article. But that's why, like, statistics by themselves don't really say that much unless you also have an explanation tied to the actual statistics. Like, you wouldn't know where to add this specific statistic in an article unless you actually had an explanation of why you should use or what it means. You can see statistic here, total antioxidant capacity for ethanol, Why are we searching that? I don't know. Let's take like, so here, prospecting medical properties of line main mushrooms. Makes sense. And then we have all these statistics, medical statistics from the articles. This was how to build a Google Scholar scraping automation in make.com. And then I'm tying it back to AiTable. And I won't lie, this is pretty complex. This is available for all the ABC members in my community. So if you want to get this right away without building it yourself, you can just go there. And of course, you'll also get all this as well. And the whole system here is built for creating articles. Hope you found it useful and see you in the next video. Bye.